network materials, tools, and devices. In this video lesson, there will be two learning competencies that you will encounter. First, identify necessary network materials in accordance with established procedures and check against system requirements. Second, obtain tools, equipment, and testing devices in accordance with established procedures. To make data transmission more extensible and efficient than a simple peer-to-peer network designers use specialized network devices such as hubs, switches, routers, and wireless access point to send data between devices. So we're going to talk about the network materials. Under network materials, we have common network cables. These cables will vary depending upon the type of network and cable they are attached to. So let us talk about first the twisted pair. It is a type of copper cabling that is used for telephone communication and most Ethernet networks. The pair is twisted to provide protection against crosstalk, the noise generated by adjacent pairs of wires in the cable. Twisted pair cable comes in two different types, the unshielded twisted pair or UTP and shielded twisted pair or STP. The unshielded twisted pair is the most common type of cable that is used today. It consists of four pairs of color-coded wires twisted to each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of network cable is what most people use in their home or business. This is the UTP looks like. Next one is the shielded twisted pair or STP. It is very similar to UTP except that it has foil that covers the wire, and this shielding adds an extra layer of protection against electromagnetic interference leaking into and out of the cable. It is mainly used for industrial purposes. So this is the example of shielded twisted pair. Let us talk about the table or the category rating of UTP. UTP comes in several categories that are based on two factors, the number of wires in the cable and the number of in those wires. These categories are called Cat 1, Cat 2, Cat 3, Cat 4, Cat 5, Cat 5E, Cat 6, Cat 6A, and Cat 7. The difference between this is the maximum speed without having crosstalk or interference. The number of categories represent the tightness of the twists that are applied to the wires, and as you can see, the speed ranges from lowest cut, which is the Cat 1, at 1 Mbps all the way up to Cat 6A and Cat 7, which has 10 gigabytes per second. So most network today would use at least Cat 6, which have 10 gigabytes per second because most network would be running at least at gigabyte speed. So sa Cat 1 and Cat 5, it is pretty much obsolete today. So let us proceed. Let us talk about the coaxial cable. Coaxial cable or coax is a type of cable that has an inner conductor surrounded by braided mesh. It was invented by Oliver Heaviside, an English engineer and mathematician. Coaxial cable used as a transmission line for radio frequency signal. It also used for cable television, LAN, and telephone. So this is the example of coaxial cable. Coaxial cable has different types. So first is the thick neck or 10 BASE5. It is a coaxial cable used in networks operating at 10 Mbps. with a maximum length of 500 meters. Next one is TNET or 10 days 2. It is a coaxial cable used in network operating at 10 Mbps with a maximum length of 185 meters. Next one is the RG59. RG stands for radio grade or radio guide. It is most commonly used for cable television in the US. And last is the RG6. It is a higher quality cable than RG59 with more bandwidth and less susceptible to interference. Next is the fiber optic cable. Fiber optic cable is a glass or plastic conductor that transmits information using light. It is made up of thousands of fiber strands, and its strand is as thin as a human hair and can carry light. It's not affected by electromagnetic interference or radio frequency interference. So this is the example of fiber optic cable. Next, we have two types of optic cable. The multimode. Multimode is the cable that has a thicker cord than a single mode cable. It's easier to make, can use simpler light sources such as light emitting diodes or LED, and it works well over distances of a few kilometers or less. The light waves are dispersed into numerous parts or modes as they travel through the cable core. The color of the patch panel is orange. Next one is the single mode. It's the cable that has very thin cord. It is harder to make, uses laser as a light source, and can transmit signals dozens of kilometers with ease. High transfer rate over long distance. The patch cable color is yellow. Let us talk about network devices or terminals. So we have hubs. Hub is a small, simple, inexpensive device that joins multiple computers together. The purpose of the hub is to connect all of your network devices on an internal network. These are devices that has multiple ports. These are devices that accepts Ethernet connections from network devices. Hub is considered not to be intelligent because it does not filter any data. Only thing that Hub knows is when a device is connected to one of its ports. So when the data pack arrives at one of its ports, is copied to all of the other ports. So all the devices that on Hub sees that data copied. The data pack that comes into one port, then the hub will just rebroadcast the data to every port that has devices connected to it. So let's say this computer wants to send data to computer C. Once hub received the data comes from computer A, the hub repeats out to every port. So kung itong PC na to gustong mag-send ng data dito sa PC 3, kapag yung data pumasok sa hub, si hub, uulitin niya lang yung data at isa-send yun para sa lahat. Okay? Next, Ethernet switch. Unlike a hub, a switch is intelligent. A switch can actually to learn the physical addresses of the devices that are connected to it, and it stores these physical addresses called MAC or Media Access Control addresses in its table. MAC or Media Access Control is a unique number that is stamped into every NIC. When a data packet is sent to switch, it's only directed to be the intended destination port. Unlike hub, when the data packet sent, it broadcasts the data to every port. As an example, if there is a computer here and this computer wanted to communicate to PCA, the data packet arrived at switch, then the switch look at its table of MAC addresses and matching and delivering data to the correct ports. And the data packet will only go to that computer. Yung isang PC, magsasend ng data kay PC A. Ngayon, yung sinend na data, babasahin ni switch sa kanyang table para makita kung ano yung correct addresses. Ngayon, kapag nakita niya na MAC address yun ni PCA, ngayon, yung message para kay PCA, mapupunta lang kay PCA, hindi mapupunta kay PCB at PCC. So, ayun yung pinagkaiba ni switch at ni hub. Next, bridge. So, bridge introduced to combat some of the shortcomings of hub. They used to segment networks into smaller sections. When data reaches the bridge, it decides whether or not to forward the data it does by looking at the destination and source and MAC. Bridge has a fewer ports. It is used to divide a LAN into multiple segments. It stores that MAC address of PC available in network and it reduces traffic. So, bridge is introduced to combat some of the shortcomings of hub. They used to segment networks into smaller sections. When data reaches the bridge, it decides whether or not to forward the data. It does this by looking at the destination and source and MAC addresses. Every time the bridge receives data, it learns the source and look at the destination address and decide to send the data or discard the data where we look at. For example, this computer want to send data from AAA. Ngayon, pag send siya ng data kay switch, ito yung segment 2. Okay? Sa segment 2, wala naman dyan si AAA. Okay? So, papapuntahin niya ulit yan sa kabilang segment. Ito yung another switch. Sa switch segment 1. Sa segment 1, hanapin niya ngayon dyan sa table niya kung nandyan si AAA address. Then, kapag nakita niya, isi-send niya lang dun sa MAC address ng AAA. Hindi yun nakukuha ni CCC. Okay, gets po ba? Okay, next. Let's proceed on patch panel. Patch panel is a panel with an array of Ethernet ports on the front and place to punch down. It helps user, especially the admin, to identify connections to computer to other sources like printers and servers. So, this is the patch panel. Kinakabit yan sa mismong pader. Next, modem. Yan. Modem, alam ko lahat kayo familiar dito. Modem comes from the word modulator and demodulator. Modem established and maintain a dedicated connection to your internet service provided to give you access to the internet. Modem demodulates the incoming analog signals into digital signals so that the computer can understand it. Modem also modulates outgoing digital signals from a computer into an analog signal as it goes out on the internet. So this is the example of modem. Next, router. Router comes in after a modem. Almost everyone who has internet connection in their home would have a Wi-Fi router. It routes and passes interconnection to all of your devices in your home or business. It allows multiple wired and wireless devices to join together in a local area network. It broadcasts a Wi-Fi signal so that the wireless devices can connect to it, and it also have built-in switch with several network ports so that the wired devices can connect to it using Ethernet cables. Next is the wireless access point. It is a wireless hub that used by wireless devices to connect to an existing wired network. WAP connects directly to an organization router where the router is connected to a modem which gives the wireless devices access to the internet. It is used by medium or large organization, and that organization will have multiple access point to make sure it covers the entire building. It has no one port. Hindi katulad ni router, meron siyang WAN port or one port. Ano yung pinagkaiba ni router, wireless access points, and modem. So, makikita niyo yung sa likod. Okay, next is the network interface card. Next is the network interface card. Ayan. Network interface card is a device that connect a client computer, printer, or other components to your network. So, nilalagay yan sa loob ng ating mga system unit. It consists of small electronic circuit board. So, let us proceed to other network materials. Meron tayong RJ45. Kinoconnect natin yan sa ating UTP cable. Next one is the cable raceways. Cable raceways is an enclosed conduit that form a physical pathway for electrical wiring. Next one is the cable clamps and fasteners. It is used in keeping network cables from tangling or trying to bundle cables in a professional wiring installation. So that is for today. Thank you for listening.